Hello and welcome to this video. We will be learning about operations with matrices by Bryn. This will include addition, subtraction, and multiplication. So first off, with the addition, there are two rules. One, the matrices, matrices is plural, matrix is singular. The matrices have to have same dimensions, meaning if you had, let's say a 2 by 3, you could only add it to a 2 by 3. If you had a 5 by 100, you could only add it to a 5 by 100. The second rule here is that you have to match up the elements, meaning that you could only add to, like say you have a 5 in row 1, column 1 of your first matrix, you could only add it to the number or variable in row 1, column 1 of the second matrix. So let's get a different color and I will show you a small example. Let's have matrix A, B, A1, A2, just a small little example, and then we'll have B1, B2, inside matrix B. So this is like regular first grade addition. This A1 here matches up with this B1, and then this A2 here matches up with this B2, and then you just add. So A1 plus B1, oops, and then A2 plus B2. And that is your sum of adding A and B together. So let's grab another example, and this time we'll use a little bit bigger matrices and as well as real numbers, and we'll include some variables. Let's have matrix X and matrix Y. So let's have X, 6, 9, 2, Y, 3. Actually, I should probably not have those variables be X and Y, since we already have X and Y as the names of the matrices. Let's have A and B again. And then Y, let's have, let's do 6, and then 9, and then 3, and then 4, and then 7, and then a B. So we need to add these two matrices together. Your A and your 6 goes together, your 6 and your 9 goes together, your 9 and your 3 go together, and then your 2, running out of shapes here, and your 4 go together, and then your B, and then your 7 go together, and again the 3 and the B go together, sorry. Okay, 8 plus 6, we'll have 6 here, 6 plus 9 is equal to 15, 9 plus 3 is 12, 2 plus 4 is 6, B plus 7 is B plus 7, and then 3 plus B is, well, we can have it 3 plus B. So that is the sum of what you would get if you were to add X and Y together. Notice again, these matrices here are the same dimensions, and the sum here is the same dimension as the two matrices. So now let us move on to subtraction, the wonderful, wonderful subtraction. The rules here are 2, which is 2, and they're the same as the addition. The dimensions must be the same, and then you are to subtract the matching elements. Now, a little way to help with subtraction is to kind of distribute a -1 throughout the entire matrix C that you're subtracting by. So let's get two little matrices here. Let's do, I don't know, D, and then we'll have little 1 by 2, D1 and D2, and then we'll have F, which will be F1 and F2. And then we do need to subtract F from D. Again, you can think of it as you're multiplying this matrix here by a -1. So let's see, D minus 1 times F1, oops, curves. So here we are. Distribute the -1 throughout there. And you can actually, once you distribute this negative throughout the matrix, you can just add it. So -F1, -F2, and then just subtract, add them, and you would get D1 minus F1 and D2 minus F2. So same dimensions, and then the elements are matched up, as you can see. And we'll give you another example. Let's have it be a little bigger, as well as have some variables. So let's have M, and we'll have N over here. Let's do a 3 by 2 once again. So we'll have X, and then we'll have 9, then we'll have 6, 7, Y, 3. So that's M, and then N will be Y, 6, 7, 4, 2, 0. So we need to subtract N from N, distribute the -1 throughout N, which will give us -Y, -7, -2, -6, -4, and then 0 doesn't really change. So we now have X, 6, Y, 9, 7, 3, plus this -Y, -7, -2, -6, -4, and then 0. This will give us X minus Y, 9 minus 6 is 3, 6 minus 7 is -1, 7 minus 4 is 3, y minus 2 is just y minus 2, and then 3 plus 0 is 3. So that is our difference here. Notice, again, dimensions are the same throughout the whole thing, and then you just multiply your subtracting matrices by -1 and then just add it. So now we'll move on to the multiplication. Now for multiplication there really isn't any sort of rules. You kind of just distribute the number that you're multiplying the matrix by throughout the matrix, and then you'll get your product. So let me do a little example because it's easier to show you. We'll have 11x multiplied by 6, 2, 3, 9, 8, 7. So we need to distribute this 11 throughout the entire thing. So I'll show you what that looks like when you do distribute it throughout. 11x times 6, 11x times 2, 11x times 3, 11x times 9, 11x times 8, and 11x times 7. So that is what this up here looks like when the 11x is distributed throughout the matrix. Now we'll move on to give the final product, which would be 66x, 22x, 33x, 99x, 88x, and 77x. So, as you can see, our original problem here went to our final product here through these little steps. So I'm going to do one more example to show you multiplication, and then I'll end the video because that's all I was going to cover. Let's do 5 because 5 is a nice little number. We'll do 2, 6, 8, 9, 1, and 0. So distribute the 5 throughout here. We'll get 5 times 2, 5 times 8, 5 times 1, 5 times 9, 5 times, oops, I'm sorry, I didn't realize my mistake there. Now 5 times 6, 5 times 9, and then 5 times 0. So that is what the 5 looks like distributed throughout the matrix. And then we'll move on to get our final product. 5 times 2 is 10, 5 times 8 is 40, 5 times 1 is 5, 5 times 6 is 30, 5 times 9 is 45, and then 5 times 0 is 0. So this is what multiplication for matrix looks like. You have this, and then you distribute it throughout the matrix. You'll get this, and then you multiply, and then you'll get that. So that is the end of the video. I hope you have a nice day, and goodbye.